The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, and welcome to today's webinar hosted by EnerNex, titled Grid Modernization, Are You Ready? I'm Carrie Owens, and I'll be moderating this session. I just have a couple of housekeeping items before we get started. One, know you have the opportunity to submit text questions to today's presenters by typing them into the question pane of the control panel. You can send in your questions at any time during the presentation. We'll collect these and address as many as possible during the 15-minute Q&A session. And then the second thing, attendees will receive a follow-up email within 24 to 48 hours with a link to access the recording of today's webinar. And with that, I'd like to now introduce the speaker for today's session, Dr. Aaron Snyder, EnerNex's Director of Grid Technology Consulting. Aaron's technical expertise includes advanced metering infrastructure requirements analysis, electricity metering standards, both national and international, distribution systems, and power system wide area stability and control. He assists utilities and vendors with developing requirements for technology, defining test plans and procedures, particularly for the cases of suspected failures, and evaluating the results. He has also provided procurement support through assisting with developing requests for proposals and evaluating proposals against those RFPs as part of grid modernization activities. Aaron worked with vendors and utilities to develop and implement an AMI test bed focused on communications networking performance and interoperability. Aaron was the deputy project manager for the EnerNex team contracted through NIST in support of the Smart Grid Interoperability Standards Development and Harmonization Project. He is a senior member of IEEE. And with that introduction, Aaron, the floor is yours.
Thank you, Carrie. Good afternoon. My name is Aaron Snyder. I'd like to thank Carrie for helping me out with presenting this webinar and with the logistics. And I'd like to thank the hosts for providing me a physical location and quiet space to give this webinar during my travels. So, for those of you who don't know, EnerNex is a research engineering consulting firm based in Knoxville, Tennessee. We were formed in 2003. We have a lot of folks who are well-trained in research, who have done the engineering working for vendors or utilities, and that leads to how we can do our consulting because we have an understanding, an in-depth understanding of what's going on in the utility business area. We understand the grid essentially from the bottom to the top. We have a group of folks who understand how to do detailed analysis, and as we move along the spectrum towards high-level strategy and helping utilities and vendors achieve their goals. That being stated, talking about grid modernization, are you ready? So it'll be helpful to understand what is the context of grid modernization, then some thoughts on what it means to do a readiness assessment. It's fine and dandy to say you want to do something, but are you really ready to do it? And then I thought I'd conclude with hopefully something, a set of controversial slides, or maybe not controversial slides and topics, to give you an idea of some forward-looking items that will have to be considered in this next wave of investment and modernization in the utility industry. So first of all, this context of grid modernization, you can think back through different things that have had the word grid in them over the last 15 to 20 years. And a few years back, we had the intelligent grid and at the early turn of the century. And that was really some thoughts around how can we do things better, moving from electromechanical meters, let's say, to solid state meters and leveraging that. How can we put communications and leverage that communications for field devices? How can we improve our back office systems? Mid-2000s, the mid-aughts, we had this modern grid initiative, and the smart grid era kind of began in the same point in time. So we had a collection of stakeholders across utility industry The graphic there to the right is kind of showing one way to slice it, and we used to slice it back then to help folks understand who was doing what. But you really had this collection of federal, state, and private stakeholders across the spectrum of policy and regulation, vision and operating models, systems integration, and technology research and development that were all looking at what can we do better from their particular perspective, and are working together across these particular topics to achieve their goals. Grid modernization is leveraging kind of this whole evolutionary era we're going through in the last 20 years or so. And we're improving or increasing the amount of data that we collect and can then ultimately use to manage and control the power system. We're putting out faster sensing and controls because we've understood that while we do a good job with the people and systems we have, we can make it even better if we could just do it a little faster. As you know, we're starting to see more pervasive distributed energy resources, and I'll show a definition of what that means, as it kind of means a lot of different things to a lot of different people. But in a sense, that's blowing up our paradigm of how we used to operate, particularly the distribution system. As you know, there's a lot of infrastructure investment and application investments. By application investments, I mean systems, anything that ends with the word system, which we'll talk about. What this is really leading to is transformation of the utility enterprise, and that's at any level, at any makeup. It doesn't matter whether you're a rural electric co-op, a municipal operator, an investor-owned utility, a market operator. This type of investment and use of technology is creating transformation. And of course, all of this is being driven to a certain degree by, we have this overlay of communications that we're using, and we've recognized for a long period of time that communications evolves at a different pace than the utility system and the utility arena. So one of the critiques that we heard a fair amount of back in what was called the smart grid era is no one could define it. Well, I hate to kind of continue that theme, but we tend to define these things by attributes. You can't say, I have the intelligent grid, because there's no way to measure the intelligent grid and say it's intelligent compared to everything else, and obviously it is the one. The same way we can't say we have the modern grid, that's defined by attributes, or the smart grid. We make things more intelligent, more modern, more smart, or what we're calling grid modernization now, by defining it through attributes. What that means is, you can't just say, at some point in the future, I will have modernized my entire grid. So if you've done anything around resilience to improve resilience, you're typically modernizing your grid. If you're improving the reliability and making investments in technology to do that, or hardening or any other investment, you're modernizing your grid. You're not letting it stay the way it was. You're enhancing security. As we know, that's a pervasive theme. You're improving or adding additional affordability or flexibility. So you're changing the resource mix. You're changing the way it's operated to allow you to perform better or meet your client's needs, or your customers' needs, or your members' needs, depending on how you name them. And in many areas, we're looking at increased sustainability. I don't know if it's still taught this way, but when I was going through undergraduate and grad school, we always said there's only 100 years of coal left. And I'm pretty sure we keep saying there's always 100 years of coal left, because we keep finding ways to leverage natural resources, but those sometimes aren't sustainable. But we're increasing our sustainability today by looking at a more diverse resource mix, as one example. What we've done recently is leverage technology, and in recent times that has meant using smart meters, or advanced meters, depending on how you would like to call them, which is really something that measures energy and two-way communications and some control, and perhaps communications into the home or another third-party network that's not under utility control. So that has been something that's been going on for quite some time. Phaser measurement units are being more widely deployed now that there's communications that can keep up with the data needs. And this is really giving utilities much more granular visibility of what's going on, particularly on the transmission system. These two concepts, and leveraging the information and measurements and communication permeating through the distribution grid. So the distribution automation, substation automation, and advanced protection are also leveraging this two-way communications. And we've seen recently there are some peer-to-peer two-way communicating distribution automation protection schemes that don't require operator intervention and allow the grid to be more flexible when it's faced with a contingency. And then there's customer domain equipment. So by using the term domain, I'm kind of referencing implicitly the NIST conceptual model, but what this means is stuff behind the meter or stuff that is not owned by the utility. So that could be thermostats or controls that allow the customers to participate in demand response and help the grid. It could be electric vehicles, electric vehicle service equipment or charging stations. It could be solar panels or other generation. Really anything that could be considered a technology that can help with the health of the grid or does impact the grid if it's aggregated. So that's really been the case for the last at least 15 years, maybe a bit longer, a bit shorter, depending on how you want to view it. Those technologies lead to systems we need to manage the technology. Generally speaking, smart or advanced meters lead to using a meter data management system. And this really allows that much greater collection of metering information to be validated, for other work to be done upon it and managed for the utility upstream applications. It also leads to generally improved outage management systems if that integration is part of what they're doing or if they leverage things like outage and restore flags. The phase of measurement units can help you enhance your energy management system and your state estimation, or back in the research that we did, it was, can you just calculate the state? Do you really need to be running an estimator when you have direct measurement of the state at a number of points in the network, and is that sufficient? So it can enhance or replicate or serve as an overlay for applications. The automation leads to advanced distribution management systems or advanced protection schemes where you can really leverage the computing capability of those devices and the communications and the ability to develop peer-to-peer schemes to really help create a more flexible grid. As I just mentioned, that customer equipment leads to needing to manage it. Uncoordinated, widespread, solar generation, as an example, could potentially create havoc depending on how it's handled at the distribution system level. And it's often better to have a management system for that. You can also do that for demand response. And in fact, some vendors combine those together because whether at some point in time that resource might be a generator or a load, depending on its operating mode. But all of these systems and these technologies generate data, and we've asked them to do that by design. We tend to like to have more data even if we don't immediately leverage it, because we can go back and look and see what happened at the worst. But if we're trying to leverage it in real time, this is really pushing the edge for this industry anyway, pushing the advanced technology needed for information technologies and operational technologies, and certainly storage and retrieval technologies. How much of that data needs to be kept actionable in a real-time database versus can I just get at it when I need to do some studies? And then analytics technologies. Now these analytics technologies and storage and massive amounts of data aren't new worldwide, they're new for the industry. So the financial sector has a lot of tools for this. And in fact, we're starting to see some crossover between what's happening, what has been happening, and the tools that are used in the financial sector crossing over into the power system or the power industry. To a certain extent, we might think that first wave or last wave is getting close to having been exhausted. So we had some reasons for putting out certain technology 5 years ago, 10 years ago, 15 years ago, and have we gotten all the value out of them, or have we kind of run the asset to exhaustion and we're ready to replace it? There's a lot more data than some of the early smaller use cases where we just wanted to have interval energy data and maybe a disconnect switch for a meter, for example, or we just wanted to be able to more quickly work our reclosers using fiber optics and some new relays. or we needed phaser measurement unit data from 5 locations. But that all created a lot more data than we can usually use for our normal operations. So to a certain extent, some of the business systems did not evolve to leverage that, or it was just overwhelming. The challenge of upgrading the rest of the utility infrastructure to handle the data from the different applications for maintaining the business can't be understated. Some of those investments are now going to be reaching their end of life, and we define life a couple different ways. There's the design life, there's the operational life, there's the depreciation life. But if something was put in 15 years ago with a certain communications technology, we're probably not even using that anymore, particularly if it was wireless or cellular telephone based. And for an electronic instrument, the design life is that long, but the operational life, you're kind of getting to the end where you need to refresh it or think about replacement. Also, we're starting to see with that two-way power flow in the distribution systems from all the distributed energy resources really changes how we design and think about protecting that system. And so we're starting to see some early designs to really take that into account. Another important element to this is we say we want resilience, but that's often difficult to measure. It's sort of like an attribute. I can say I'm resilient, but until I'm tested, I don't know how far I'm resilient. I can only be resilient so far. So I can say I want a backup generator, that makes me resilient. And then I say, well, I don't want to just have diesel, I want to have natural gas. Well, that's a little more resilient. And then maybe I need a standby battery to cover until the generator starts. Well, that's an important part of the design. But then what if I run out of fuel and the natural gas infrastructure is disturbed during, let's say a major event? Well, then I'm actually not resilient at all. I didn't have that extra element. So again, we can only be resilient to a certain degree. There's no 100% assurance. And it's important to remember technology won't solve all the problems when there's a major issue. So there's no technology that will protect us from every disaster. And so we can't hold that as the goal and be measured against that. I'm thinking that, well, you deployed this technology, so for sure you would not have suffered any kind of disaster. So that's sort of the context for what grid modernization is. What I'm going to talk about next is what we consider a readiness assessment sort of, framework and methodology that we tend to use with our clients every so often, and maybe even right now. And it's really thinking about how you can approach these projects and make sure that you're ready. So I'm using an analogy to something you probably know, which is ready, aim, fire. So this is ready, define, buy. And the analogy is important because are you really ready? And at what point are you ready enough? You don't have to be perfectly ready, you have to be ready enough. Have you done enough definition to be ready to do the purchase? So that means that the purchase isn't done without some degree of readiness, without some degree of definition. Otherwise, it can be seen as a wasted investment, or you may not fully leverage that investment. What that tends to include is, do you have a strategy? Do you have an architecture? Do you understand what the requirements are? So have you gone through even implicitly a use case exercise to know what you need? Do you know how to specify what you want? Are you good at doing an RFP? Do you feel comfortable in doing an RFP? And how can you measure that degree of comfort? And then this is often kind of what's not included, but can you test what you get to know that your requirements were met and that you're satisfying the strategy that you started with? And can you evaluate that technology in an objective fashion to achieve that? So all these things can be tied together, and they are generally tied together, if not specifically. So starting off with, are you ready? Most folks understand the regulatory drivers and their business drivers, particularly for their particular utility business model, and they've created, to a certain degree, or they understand what their stakeholders are interested in. Are their stakeholders, safe, reliable power, probably number one. Number two, do the people care more about renewable energy sources? Do they care more about reliability? They want all of that. What are these stakeholder concerns? And do you have a roadmap for where you're headed, not just for one particular project, but for modernization as a whole. It's not just go out and buy a bunch of systems, say I was modern because I bought new systems, and the integration falls to the wayside, or you haven't invested in your IT and OT to support that. Do you understand what systems you actually have? Do you have an as-is architecture with a few different levels, or as many as you need, to characterize what you actually have today? Or is it, I have a bunch of experts, which you tend to have a lot of experts, but we haven't documented it and talked together and really found a way to articulate what we're operating. Are they integrated at all, and how well are they integrated? Is it, well, I export a file from one system and import it into the next because we never figured out the integration, or I export it into one format, convert it to a different format, tweak it, and then import it. And why was that process put in place? So have you documented the process behind doing what you're doing to get to knowing where you are? So it's very important when you're starting a journey, particularly a modernization journey, to know where you are before you define where you're going. The next component of this, which can be helpful, is to benchmark yourself. So now that you know where you are, can you look around and see what everyone else is doing? Do you know where you are with your IT or your OT, your system architecture, your integration technologies? Are you relying on software that's 20 years old? Are you relying on the latest and greatest? Do you have staff that can support that? Do you have systems? And then where are you with respect to the market and versioning for those systems? Are you running a GIS system you bought 20 years ago and the provider is no longer in the market? Have you always applied patches and upgrades and you feel confident? Is your database technology keeping up with these systems? Where are you with your operational technologies? Are they integrated into your workflows? Are they integrated into what you're doing today or where you want to go? Or can you imagine how that could be the case? Where are you with your enterprise resource planning software? Is it homegrown? Is it a big provider? And then what hooks do you need to achieve your business objectives? I mean, meter to cash, protection to recovery, disaster recovery, operations, and including the rest that's related to this. Can you run your business? And then what's your organizational structure? Are you, if you measure your peers or measure the industry or look into it, are you overstaffed, understaffed, perfectly staffed? Do you have the kind of structure that lends itself to cross-fertilization, cross-pollination? Do you have your procedures well documented so everyone has a good feel for taking on different roles, let's say in the case of a disaster? So once you've done this, can you measure yourself? So one way to do this is to map this out. So I'm showing an example here, and they're intentionally fuzzy because the details aren't as important as the methodology. So if you can chart where you are and where you want to go with respect to the peers in the market, you'll find a way to define your risk and your acceptance for kind of like being on the leading edge or being comfortable in selecting stuff that's maybe best in breed, but doesn't need to be the latest, greatest thing. So this particular methodology that I'm showing here, so the top is showing a measurement across a number of different dimensions. And the bottom line is where the utility is today, and the top line is where they think they want to be. And the shaded blue zone is all the other utilities against which they were measured. And so you can see where they are today is generally not within their peers across those particular measurements. And where they're headed tends to align with their peers, or in some cases, be on leading their peers. And it's okay to be the leader, just remembering that that's a risk element. And if you look at the bottom as a different portion of the same type of analysis, and you can see if you measure where you are and where you're headed against the peers, it helps you make sure you're not overbuying, overbuilding, underbuilding, or also defining your risk level. Again, do you want to be the industry leader where no one's ever done it before, or are you comfortable being in the second wave? Once you figure out that you're ready, the next important thing to do, and these things can happen kind of concurrently. There's no strict rule that one has to follow the other. It's how are you going to define what you need? We like to have some sort of foundation for it. Do you have a foundational architecture or understanding, even at the conceptual level or the data flow level, of what's going on within the utility, within your business enterprise? And do you have a framework for developing that? So it doesn't matter what the framework is. It doesn't matter how you express your architecture, but can you articulate it to the extent that everyone knows what's going on, so that when you interact with the vendor community through your RFP and the requirements that you define, they understand where you are and what you're trying to achieve, and it doesn't look new and fresh to them. We're trying to leverage their experience and not make it so that you're unique. Of course you're unique, just like everyone else, but can you do this in a way that's easy to replicate from project to project and has a foundation that is easier to defend when you need to? In some cases, you may need an RFI. Maybe you just don't know enough about it, and that's fine. There's nothing wrong with asking questions. An important aspect of that is, have you accumulated any what we would call tribal knowledge? Have you been to some conferences and talked to other utilities that you know have done what you're trying to do or thinking about doing it? Have you seen some software that does what you're trying to do, but you don't have it yet? Have you seen new control devices or new meters or new anything that you're not doing, just to see what it can do? Do you have an understanding of where the market for those systems and devices is currently placed and where it's headed? If you don't, that's fine. Do an RFI, get some information, because what you need to be able to do is better specify what you want to do and make sure that you get the best response. An important piece of that is internally, all your stakeholders need to be bought into the need for this. It's very difficult to achieve this cross-departmental, cross-fertilization, cross-benefit without the stakeholders being bought in. And a good way to do this is put them in a room and make them talk. We found that there's no real shortcut for this unless they've already been doing this on their own, is get them together and have them talk through a workflow or a day in the life. And what they're doing is articulating, without them knowing it, a use case, and they're actually, the things they're talking about are the requirements. And you can capture those down, and they'll be surprised at how much they could already do without having to do it. There's also formal methodologies for doing this, and that's a different workshop approach. But there's nothing wrong with developing the requirements in whichever way works for your organization. We also tend to want them to focus on business relevant and value relevant requirements. So unless the requirement can be tied back to a tactical need, strategic need, or business value, then it can be seen as a bad requirement. There's nothing wrong with some of those, but in general, we want to be able to measure the value, measure what we got. One way to interact with the vendor community is through your requirements, and those can lead to specifications. So the requirements are sort of the what, and the specifications can be the how. And to a certain extent, you might be able to trust existing standards and certification programs that go with those to define the technology. In some cases, you'll be doing that yourself. But that opens up the questions: are you able to test this technology that you're going to be procuring? Do you have a methodology to do that? Do you have the capability to do it, the infrastructure, or sometimes even just the patience? And what are your standards? Do you have IT and OT standards that you can use to interact with the vendors in a way that they understand where you're headed, what you have, what are your cybersecurity standards? Is any of this documented, your operating practices? They'd like to know that. We're showing some, there's two examples shown on the screen, and then a nice clip art of a certificate, but there's different kinds of standards and specifications, and there is a methodology around this interoperability process that are available to you as resources, so that helps you develop your thinking in this arena. Then you want to buy the thing, obviously. There's no fun doing all this analysis and not actually making the decision. But, and one of the things I would challenge you, perhaps as an organization, so you wrote your RFP and you think you're ready. Now let's pretend you decided you didn't want to run the rest of the process and you handed it to a third party. Did you do enough work so that you feel comfortable with them buying that for you? And I think of the analogy of, if I want to go grocery shopping and I can write down generic names, and then I know what brands I want once I get to the grocery store, I could now open up their app and pick them myself, and somebody will pick them for me and put them in the basket, and they'll shop as if they were me. But if I just handed you my list and I just picked generic items like, cereal as a reminder, and Pop Tarts without saying the flavor, and then I need some meat, you're not going to know what's in my head, and your choices are going to be different. So I wouldn't feel comfortable with you shopping for me because I didn't give you enough information to do that. And then, are you ready to have them demonstrate their technology? You don't want the trade show dog and pony show. You want a tailored demonstration that addresses your pain points. So have you written that down? Do you know what you want to see? Now, it is important to understand the overall interface, but will it meet your needs? Will it address your pain points? And again, have you gotten to the point where you've used your requirements to develop the testing? Because you're going to get maybe even a demo copy or a trial copy of a system or solution. Could you test it? Could you integrate it into your system and use it? Are you able to validate their claims? So if you've specified it has to do something, can you actually run a test to validate that they meet that something? And then what is that evaluation methodology? Is it super subjective because you've only got the one engineer who's been doing it for 30 years and you have to make him happy? Or is it across an objective spectrum with objective metrics that meets it, it partially meets it? Is there a way for you to really objectively measure this technology? So this is an illustrative example of a grid modernization project. So again, we're trying to achieve greater resilience, improved reliability, enhanced security, affordability, flexibility, sustainability. If you're familiar with the requirements language, those are all non-functional requirements because they're not what you do, it's what you how you want it to be done or what your goal is. So your grid modernization project may have some, all, or one or two, or none of these elements, but in general, what we would advocate is you need to have a strategy of some sort. It may not have all the pieces up here, it may have more, but what is the strategy for what you're doing, or certainly tactically, what are you trying to achieve? How have you defined it? Is it, I just want a distribution management system? Okay, well, that's a start, but have you done enough further definition to know exactly if you're going to meet that? Now, obviously, you could open up an RFP and get tenders for, or get responses for a DMS, but how would you measure if you got what you needed? You have to have a procurement process, and part of that is the technology analysis, the vendor analysis. Can you evaluate the proposals? Do you have the technical experts, or is it just going to be the procurement division that does it? Is there a way to do a technical score before you see the financials? What's your process around that? Then internally, sometimes what's not understood is you're actually running a project, and a very important project that includes teams that don't normally work together. So how have you put together that team? How have they been tasked with what's their operating mode? What's their ability to be flexible to meet their day-to-day job and work on this new project? Do they have the capability to make, to do change management or to make recommendations to the processes? And then have they really are they the top of the pyramid for your broader stakeholder buy-in? And then finally, when you get to the point where this thing's installed, how are you going to make sure that you're getting the full value out of that system that you're putting in? You obviously will have some experts in the company, but what other training has been built in and hopefully built into your RFP as part of the delivered system? And then how does this lead to improving your business process? So what we tend to find out, in a few cases anyway, that we start off doing a grid modernization project because somebody wants to procure a system. And we take them through the process, and they have a stakeholder team, or we help them build it. They have a project management organization or some other leadership team, and that's all fine. We help them think about the requirements. We've helped them get to an RFI or an RFP, and they're fully ready to do the buy. They want to buy the system. Maybe they've got the processes, they know where they're headed, that's all fine and dandy. But what it turns into really is an organizational modernization project. The grid mod becomes an org mod, because what we can uncover is that maybe the processes are difficult because of the systems that were involved, and that just needs to be better. We don't want to duplicate bad processes with a new shiny system. So, it's all, you can buy a faster car, but if you still don't know how to drive, that's not helpful. Or this leads to a fair amount of training or professional development opportunity or direct need. These people might be managing something they've never managed before, have to acquire skills. So there's some transformation that takes place at that level. And that's just, sometimes people are surprised by this. So, a lot of utilities are not. It's just something that's not thought of when they say we need a system. When it turns into we need to make sure our organization is ready to buy the system. All right, so now I'd like to leave you with a few controversial thoughts, maybe not so controversial, but food for thought. So if you think about the industry as a whole today, we're pretty comfortable with certain ways we generate power, deliver power. We've got distributed energy resources everywhere, but there's still some challenges when we want to do this. And one of them, it's not really a crystal ball, it's more of a challenge, is we're looking at direct current again. What's old is new again. Direct current is great. We've got a lot of resources that are direct current based, so solar panels, and then we have inverters to convert that to AC power or AC electricity. One of the issues, though, is a lot of those technologies have their own output level, and so each technology isn't just having a voltage that's the same. And what that leads to is, as an example I'm showing, so there's an AC to AC transformer, and you see in one case it's 480 volts on one side transforming down to 347, which is already sort of an odd number, but that's then not the same as the other energy device, which has a inverted 380 volts AC to 480, and in the third one, which is 315 to 480. Well, what we're not doing there is leveraging economies of scale and standardization. And so if we have a bunch of different pieces of equipment for different levels, we can't pool our knowledge and leverage the knowledge that we've developed over the years, because we have a new unique device that no one's built before. Now, it's still a transformer, but it's at different voltage levels and has different characteristics that we're not used to operating. So it'd be nice if we can find a way to have some sort of standardization. The protection in DC is also even more critical. There's no sine wave to leverage for protection. And it kind of goes beyond what we're talking about today, but for you protection engineers, you know what that means. There's no safe point where there's no zero crossing to leverage. And then finally, surprisingly enough, there's really no yet standardized way to do DC metering. We do AC metering all the time. We have a national watt hour, and we understand that very well. But DC metering is a frontier. And how are we going to do it when all the different voltages are different? Now, they would all perhaps be converted to 5 volts, which is what we do for AC, or 20 volts or whatever. But for DC, how do we know to do that? And then we're talking again about a lot of non-standard devices to do this. Let's move to our friend distributed energy resources, and I'm saying it's complicated. It's complicated because if you see in the upper left, if I just try to define distributed energy resources, and some of you are going to say, well, that's the solar panel. All right, well, that's fine. It's distributed generation, right? It's generation somewhere in the distribution system. It could be oil-based, it could be wind, it could be solar, it could be a battery, but a battery is also storage, weight. And what kind of battery is it? Then we have, by some measure, energy efficiency as a distributed energy resource. And then we can call different operating regimes distributed energy resources. It's demand response, demand side management, direct load control, frequency responsive load. So DER as a general category is complicated, and each one of those has different characteristics. It also covers over or goes across the boundaries of several different domains. Batteries, or let's say generation technologies distributed around the grid that aren't big enough to be what we would call a central station, is a distributed resource. So it kind of crosses over all the different domains that we think of, whether it's control or communication. So it's complicated. It's just not that simple to say I have DER and the problem is solved. And then finally, humans like patterns and replicable patterns. So if we have a microgrid, we can have that microgrid anywhere. It doesn't have to be a microgrid on the distribution system. It doesn't have to be privately owned. It could be publicly owned. It could be utility owned, but it has certain characteristics that we might be able to consider to be in common. It might have communications that could be in common. Another pattern we like to help understand or helps us decompose this complicated system is how do we operate it? How does the market look? So we've got different organized entities to manage and operate the system and to organize this exchange of electricity. Is it a direct sale market? Is it an exchange market? Is it an open market? How do we measure the value of the resources and ensure that there's the transactions that are taking place are secure and reliable, that the financials don't fall apart because of some issue, that the technology doesn't lead to financial problems. So operations and markets are going to be evolving, particularly if we consider the concept of distribution system operator. It's not just the IOU distribution department. It's a distribution system operator, which has a competitive nature to it for all the resources and the infrastructure that's there. I'm not saying we want duplicate infrastructure. We don't need that, but we have in many cases, but we do need the sense of a competitive market at that level, perhaps in the future, to help us alleviate some of the other concerns that I've been talking about today. So hopefully those weren't too controversial, but if they are, that's fine. I'm willing to discuss and expand my mind. So with that, I'd like to thank you again for your time this afternoon and open the floor for questions.
Thank you, Aaron. And actually, I think this is going to conclude today's session. And just a reminder for those on the line, should you have a question after the fact, we encourage you to visit www.enernex.com or you can email Aaron directly. We also invite you to connect with EnerNex on Twitter and LinkedIn. Now, once we conclude today's webinar, you will receive a survey on the presentation, and we would appreciate if you would take a moment to provide your feedback. Thank you. And you'll also receive a follow-up email within 24 to 48 hours with a link to access the recording of today's webinar. And so with that, on behalf of EnerNex, we thank you for joining us. Have a great rest of your day. Thank you to Aaron. And this concludes today's webinar. You may now disconnect. Thanks, everybody. Bye-bye.